The story of China's modern air power is one of remarkable transformation, a journey that began with humble, often challenging, origins. For many decades, the People's Liberation Army Air Force relied heavily on aircraft derived from Soviet designs. Early jets like the Shenyang J-5, a direct copy of the MiG-17, and the Chengdu J-7, based on the iconic MiG-21, formed the backbone of China's aerial defenses. China's aviation industry spent years mastering the art of reverse engineering and licensed production, a crucial but slow phase of learning that laid the groundwork for everything that would follow. This reliance on foreign technology created a significant capabilities gap between China and Western air forces, a gap that became glaringly obvious by the 1980s and 1990s. This led to the development of the Chengdu J-10 Vigorous Dragon, a significant milestone. The J-10 was China's first truly indigenous fourth-generation fighter, a multi-role aircraft that showcased the growing maturity of the country's aerospace sector. Chinese engineers and designers learned about advanced aerodynamics, fly-by-wire flight control systems, modern radar technology, and powerful turbofan engines. Having mastered the complexities of fourth-generation fighters, China's leadership set its sights on an even greater prize, a fifth-generation stealth fighter. The goal was no longer just to match existing Western capabilities, but to challenge them directly. The ambition was to develop an aircraft that could operate undetected in hostile airspace, giving China a decisive strategic advantage. The world got its first glimpse of China's stealth ambitions on January 11, 2011. On that day, a large, angular and futuristic-looking aircraft took to the skies over Chengdu, its twin engines roaring. This was the maiden flight of the Chengdu J-20, nicknamed Weilong or Mighty Dragon. The timing was no coincidence. It occurred during a visit to China by the United States Secretary of Defense, sending a clear and powerful message about China's rising technological prowess. The J-20 was a stunning revelation, a physical manifestation of China's goal to become a top-tier military power. Its appearance alone, a long fuselage, canard foreplanes, and chiseled angles, showed that this was an aircraft designed from the ground up with low observability, or stealth, as its primary characteristic. The J-20 Mighty Dragon is a heavy twin-engine single-seat fighter designed for air superiority and precision strike missions. Its key features include a blended wing-body configuration, which helps reduce its radar cross-section, and a large internal weapons bay capable of carrying a variety of long-range air-to-air and air-to-ground munitions. By carrying its weapons internally, the J-20 avoids the radar reflections that externally mounted bombs and missiles would create, preserving its stealthy profile until the moment of attack. Powering the Mighty Dragon has been a central part of its development story. Early prototypes and initial production batches were fitted with Russian-made AL-31F engines, a reliable but older design that did not fully unlock the J-20's performance potential. The ultimate goal is to equip the entire fleet with the powerful WS-15 engine, which is designed to enable supercruise, the ability to fly at sustained supersonic speeds without using fuel-guzzling afterburners. The J-20 is also packed with advanced avionics and sensor systems. It features a large, active electronically scanned array radar, which is more powerful, jam-resistant, and harder to detect than older mechanical radars. In addition, it is equipped with a distributed aperture system, a series of optical sensors placed around the airframe that provides the pilot with a 360-degree infrared view of the surrounding environment. Stealth technology, more accurately known as low observability, is not about making an aircraft completely invisible. Instead, it is a combination of design features, materials, and tactics that work together to drastically reduce an aircraft's signature, making it incredibly difficult for an enemy to detect, track, and engage. For example, a conventional fighter might be detected by a powerful ground radar from 200 miles away, giving the defender ample time to launch interceptors or surface-to-air missiles. A stealth aircraft, however, might only be detectable from 20 miles away, a range so short that by the time it is seen, it may already be too late for the defender to react effectively. This reduction in detection range is achieved through several key methods. The first is shaping. Stealth aircraft like the J-20 are designed with flat, angled surfaces, known as faceting, that are carefully aligned to deflect incoming radar waves away from the radar receiver. The second method involves the use of special radar-absorbent materials. These are coatings and composite structures applied to the aircraft's skin that are designed to absorb radar energy and convert it into a tiny amount of heat. rather than reflecting it. But radar is not the only way to detect an aircraft. Modern defense systems also use infrared sensors to track the heat signature from an aircraft's engines and from the friction of air passing over its skin. To counter this, stealth fighters incorporate features to reduce their infrared signature. Engine nozzles are often shaped to mix hot exhaust gases with cool ambient air. Furthermore, stealth involves managing electronic emissions. A fighter's own radar is a powerful transmitter that can give away its position. Advanced systems like ESA radars can use low probability of intercept modes, which spread their signals across a wide range of frequencies, making them seem like random background noise to enemy sensors. The strategic importance of stealth in modern warfare cannot be overstated. It allows an air force to seize the initiative and control the terms of engagement. A stealth fighter can penetrate deep into heavily defended airspace to eliminate critical targets, such as enemy air defense radars, command and control nodes, and surface-to-air missile batteries, paving the way for follow-on strikes by less stealthy aircraft. In an air-to-air combat scenario, a stealth fighter can detect its opponent long before it is detected itself, giving its pilot the crucial first look, first shot, first kill advantage. The introduction of the J-20 Mighty Dragon represented not just an evolution, but a revolution for the PLA-LAF, marking a clear break from all previous generations of Chinese-built fighters. When compared to its predecessors, such as the J-10 Vigorous Dragon and the J-11 Flanker series, the J-20 is fundamentally different in its core design philosophy and mission profile. The J-10 and J-11 are classic fourth-generation fighters, designed primarily for maneuverability and carrying a large external payload in a head-on aerial fight. One of the most visible and significant differences is the J-20's internal weapons carriage. While a J-10 might carry its missiles and bombs under its wings and fuselage, creating a large radar signature, the J-20 conceals its entire combat load within internal bays. This is a defining feature of all true stealth fighters. This internal carriage keeps the aircraft's surface aerodynamically clean and, more importantly, electromagnetically quiet. Another major advancement lies in the J-20's sensor fusion and avionics architecture. Older jets like the J-7 and even early models of the J-10 presented the pilot with raw data from different sensors on separate displays, forcing the pilot to mentally combine the information to build a picture of the battle space. The J-20, like other fifth-generation aircraft, uses a concept called sensor fusion. Powerful onboard computers take data from its AESA radar, distributed aperture system, and other passive sensors, and integrate it all into a single intuitive tactical display on a large cockpit screen. Ultimately, the J-20 represents a shift in strategic thinking for the PLA-LAF. Previous fighters were largely defensive in nature, designed to protect China's own airspace. The J-20, with its combination of stealth, long-range, and advanced sensors, is an offensive weapon system. It is designed to project power far beyond China's borders, capable of holding distant, high-value targets at risk. The leap from the J-10 to the J-20 is therefore not just a step up in technology, it is a profound transformation in military capability, moving China from a regionally focused air force to one with aspirations for global reach and influence. While the Chengdu J-20 was capturing headlines as China's premier heavy stealth fighter, another, different stealth aircraft was being developed in parallel by a rival manufacturer. Developed by the Shenyang Aircraft Corporation, this medium-weight, twin-engine fighter first appeared in 2012 and was unofficially designated the J-31. It was later given the export designation FC-31 Gerfalcon. Unlike the J-20, which was developed under a direct state-funded program for the PLA-LAF, the FC-31 was initially a private venture by Shenyang. The company aimed to create a more affordable and adaptable stealth fighter that could be offered on the international market as a competitor to the American F-35 Lightning II. The design of the FC-31 bears a striking resemblance to the American F-35, featuring a more conventional layout than the J-20, without the canard foreplanes. It has a single seat, twin engines, and twin-canted vertical tails, all classic features for a modern stealth design. Its development has been more iterative and public, with several distinct prototypes appearing over the years, each showing visible refinements and improvements over the last. For several years, the ultimate purpose of the FC-31 remained a subject of speculation. However, the design's potential was not overlooked. Its robust twin-engine configuration and medium size made it an ideal candidate for a role that was becoming increasingly important for China's military ambitions. a carrier-based stealth fighter. The Chinese Navy, or Plan, needed a fifth-generation aircraft to operate from its growing fleet of aircraft carriers, and the single-engine J-20 was considered too large and heavy for carrier operations. The Gyrfalcon was about to find its true calling. The transformation of the FC-31 Gyrfalcon from a speculative export fighter into a frontline naval asset marks a pivotal moment in the development of Chinese air power, as the People's Liberation Army Navy, or Plan, prepared to launch its third and most advanced aircraft carrier, the Type 003 Fujian. It became clear that a new generation of carrier aircraft was needed. The result of this naval adaptation is the aircraft now widely known as the J-35. The J-35 is a heavily modified and navalized version of the FC-31 prototype. While it retains the same basic shape and twin-engine layout, it incorporates numerous features essential for the harsh maritime environment of carrier operations. The emergence of the J-35 is a game-changer for the Plan. It will provide China's carrier strike groups with a fifth-generation stealth fighter capability, allowing them to project power more effectively and survivably across the Indo-Pacific. Paired with the KJ-600, a new carrier-based airborne early warning and control aircraft, the J-35 will form the core of a modern carrier air wing that can seriously challenge the dominance long held by the U.S. Navy, fundamentally altering the naval balance of power in the region. The rapid journey from the initial J-20 prototypes to the operational J-35 carrier fighter in just over a decade showcases the incredible speed and ambition of China's aerospace industry. This progression is not merely about building individual aircraft. It is about establishing a comprehensive, top-tier combat aviation ecosystem. China is now one of only 2 countries in the world, alongside the United States, to have independently developed and produced 2 distinct stealth fighter designs. The J-20 provides a long-range, land-based air superiority and strike capability, while the J-35 delivers a flexible, multi-role stealth presence from the sea. Together, they form a powerful and complementary duo that addresses the full spectrum of China's strategic needs. The strategic implications of this stealth fleet are profound. These jets provide China with the ability to challenge air superiority in contested regions like the South China Sea and the Taiwan Strait. They give Chinese military planners a powerful anti-access and area denial tool designed to hold at risk the high-value assets, such as aircraft carriers and air bases, that underpin American military power in the Pacific. The presence of the J-20 and J-35 forces potential adversaries to invest heavily in counter-stealth technologies and rethink their operational doctrines. It fundamentally changes the risk calculation for any military intervention in the region, creating a much more complex and dangerous operational environment for opposing forces. Looking ahead, the development is unlikely to stop here. China's aviation industry is almost certainly working on next-generation concepts, including unmanned combat aerial vehicles that could fly as loyal wingmen alongside manned fighters like the J-20. There is also ongoing research into even more advanced technologies such as adaptive cycle engines, advanced composite materials, and artificial intelligence for combat decision-making. The story of the J-20 and J-35 is therefore not an endpoint but a milestone in a much longer journey. It demonstrates that China has successfully mastered the technologies of the present and is now looking firmly toward defining the future of air combat, securing its position as a global military technological superpower for decades to come.